Okay, today we're going to be talking about something called the constant of proportionality. I know it sounds confusing, but proportionality is showing that there is a proportional relationship between the quantities x and y. Constant meaning that they are constantly the same. It is not changing. So that vocabulary word, constant of proportionality, is, like I said, showing a constant value of rate between the quantities of x and y. So if they give it to you in a chart like I have underneath, whatever comes first or is on top, that's our x value. Whatever comes second or is on the bottom, or if I had it side by side, it would be whatever's on the right, would be our y value. So if I give you bananas and the cost of those bananas, and I wanted to find out if this actually was a constant rate of change, well, let's go ahead and look at those bananas. And again, it's the constant proportionality of, let's see this one, 1 over 1, well, that's 1. 2 over 2, well, that's 1. 3 over 3, 1. 4 over 4, 1. And you can see right here that they all have the exact same rate. So that is a constant value between our x and a y. So these definitely, I've been able to prove it now with my work, they have a constant rate. And if they have a constant rate, it means it is going to be a proportional relationship. So let's go ahead and give you this first example. If I give it to you in a word problem, which they love to give us word problems to see if they can confuse us. But on this first one, I'm just saying, while working in a rainforest during the wet season, Ezra measured the rain after 5 hours and found that the rain gauge it was actually measuring at 10 inches. It was found on that day that it actually rained at a steady rate the entire day. And then they give you this question of, is the relationship between the number of hours and inches proportional? Well, I get so many students going, I don't know. They don't give me much information. But they actually give you a huge piece of information. And that's right here. In that last sentence, it was found on that day that it rained at a steady rate. If it was a steady rate, that means it was a constant rate through the day. So I can answer that actually in a nice complete sentence to say, yes, it actually was proportional. But then, of course, give me a reason why. It rained at a constant, or if you don't want to use the constant, you can use the word steady like they did. Steady rate. It rained at a constant or steady rate, which means it was proportional. Now, if I go ahead and look at a chart and they're asking me to fill in the information from this word problem, well, I'm starting with what they gave me. Notice Ezra was measuring it, and after 5 hours, he found out that it was 10 inches. So this is where they're getting the value right here in my chart. Notice my time is first, so that's my x. My rain is second, so that's my y. And all they did right there was they put in the 5 and the 10 inches from that word problem. Now, since I know it's at a steady rate, I know that whatever this proportion is right here, I have to have that exact same value on every other piece because it is a steady rate. So notice 5 out of 10, well, what rate is that? 5 out of 10, I can reduce that to 1/2. So what I need is I need all of these rates that when I'm done to equal 1/2. So let's see if we can fill in these other pieces. Well, let's start with that easy one. If I already know that it's 1 here for the time, what do I need to have on the bottom so I can get that 1/2? Well, that's almost a given. That's 2. Because once I have that 2 for the rain, it's going to give me that same ratio of 1/2. Well, again, here I need 3 hours. I've got my 3. What do I need to be in my denominator in order to reduce and get 1/2? Exactly, 6. And that last one, I've got the 6 hours. What do I need in the bottom right here so when I reduce it, it will give me 1/2? 12. Now, having a constant rate of change is definitely one of the necessities to be a constant of proportionality, a proportional relationship. But there's one other key part, and I put that right over here. To be a constant of proportionality, to actually have be a proportional relationship, you have to have a 0, point. So I think it makes sense. If I don't even start, no hours pass, I'm not starting, how much rain have I collected if I haven't even spent any time collecting it? It would be 0. So I can see there is a 0, point, and they all have the exact same proportion. Now that I know it's a 0, and it has the same steady, constant proportional rate, it is called a proportional relationship. And looking at a proportional relationship, especially in a graph, let's graph our chart. So time 0, well, let's see, 0 with the time is 0, rain, inches is 0. Let's put that on the graph. 0, 0 would be right here at that point. 0 time, 0 rain. Now let's look at that second one. 1 hour gave me 2 inches. So that's 1, 2. Go over 1 and then up to 2. Let's put that point. 1 hour is 2 inches. That next one, 3 hours gave me 6 inches. So go to 3 hours and go up to 6. Put your point. Now let's look at 5 hours gave me 10 inches. Go over to 5 hours, up to 10. And then of course we've got 6 hours, gave me 12 inches. 6 hours, up to 12. When I connect that dot, notice what happens. I should get, well, I kind of messed up my graph, but it's only because it's not on an actual graph. It would be a nice straight line. And with that nice straight line, that shows me it is linear. Linear means it's a line. That shows there's a constant rate of change. Linear is a straight line. Constant rate of change gives me a straight line. But to be proportional, it must be linear, a straight line, but it also has to be from the origin. If I do that, that shows me a constant rate of change, and it is also a constant proportionality. So this line right here, since it's straight, is linear, but since I've got a 0, point, I can actually say it is proportional and linear. Now, one other thing they're going to want us to do is actually write an equation. If I just saw that line on a graph, could I give the equation of that line? Well, I'm telling you, if it's a proportional equation, this is the formula to write that proportional equation. it will always start with y equals, and then you're going to have a number multiplied, or a coefficient multiplied to the x. That number that's going to be multiplied by the x is what we call our unit rate. It's always where the x is 1, but your y, whatever the y is going to be that unit rate. So here's x. Here's x is 1. Where did it hit the y? When x was 1, where did it hit the y? It hit it at 2. 2 is my unit rate, and 2 is also what gives me the equation of y equals 2x. This is the equation of that line. So once you have a graph and you see it starts at 0, 0, that is linear, it makes a straight line. To find the equation, you write y equals, find out where that x, when it's 1, is hitting the y, and you will then have your equation. So just another little example of what is the difference between a linear relationship compared to proportional. You can see right here, this blue line is linear. It's nice and straight. That's exactly what a linear line would look like. But it is not proportional because it does not go through the 0, 0 point. The green line is also a straight line, but you can see it does go through that 0, 0 point, which means it is proportional. And if I needed to write an equation for that line, I would see where the x is 1, and I showed you right here on this graph, if x was 1, where does it hit the y? It hit it at 3. So if I had to find the equation of that green line, it would be y equals 3x, because that unit rate is 3. So we're going to be working on that in class today, talking about that constant proportionality. So if you have any questions, bring them with you to class, and we will continue to work on it there.